Hi there, thanks for joining us. I'd like to talk about medical research and innovation around the world, which patients it helps and which patients it doesn't help. First, imagine you're Canadian and a doctor diagnoses you with high blood pressure. This disease generally has no symptoms, but the consequences if it goes untreated can be fairly serious. For example, you might die of a heart attack or suffer a severe stroke. So you'll try to lose weight, get more exercise, reduce your intake of salt and caffeine, but there's a good chance that that won't be enough in your case. Luckily, you can also get significant benefit from medical therapy. Here are your choices. In a quick search, I found 54 approved treatments, not including combinations of drugs. Most of these are safe, effective, and so on. This is for a disease that was only recognized as a problem about 50 years ago. And look at everything modern medicine has come up with. It's helped too. Cardiovascular related diseases in the US have decreased by over 50% over the past 30 years, partly as a result of medications like these. So now let's imagine another situation. Suppose you're Kenyan, and a doctor has just diagnosed you with visceral leishmaniasis, or VL. This is a very serious disease, and it's been widely recognized as such by the global medical community for over 100 years. In this case, medical therapy is your only hope. Now, we've seen the power of medical science, and if we've been so successful in finding treatments for high blood pressure, we've probably got even more treatments for VL, right? Well, something must be wrong here. Not only are there only 5 drugs available, but none of them is really very good. They all have at least 2 or 3 major problems. They're toxic, they don't even work very well, they're hard to use, they're expensive, or they simply haven't been thoroughly studied so that we don't really know who to give them to and whether they work and what kind of toxicities to expect. Now, you're probably wondering, am I just cherry picking diseases here? Did I just pick some rare disease that happens to not be well treated? Well, let's take a more global perspective on this. So here are a few of humanity's major diseases and disease categories, and the colored bars show how much of the global health burden each of them is responsible for. Heart disease, cancer, AIDS, tuberculosis, malaria, and other tropical diseases. 5 years ago, some researchers looked into how many new drugs had been developed for each of these diseases over the past 25 years. And let's see what they found. Well, that's what we would like to see, right? Ideally. Unfortunately, that's not what they found. In fact, there were plenty of new drugs for cancer and heart disease, but not so much for those other diseases. Now, in showing you these results, I'm not saying we have too many cancer and heart disease drugs, but rather cancer and heart disease show how much we are capable of. And so we have to wonder, why haven't we achieved those kinds of results across the board? Are these diseases intrinsically harder to treat? Or are we just not trying as hard? Now, to answer this question, we first need to understand what some call the drug development pipeline. We'll go through an overview of each step in the development of a new drug, and importantly, how each step gets paid for. We generally think of 3 steps in the pipeline: discovery, development, and delivery.